So I welcome you to this session, and this is the very first session for Math 110. So in this session, I will just give you the course content of this course, and also I will try to share the mark distribution, that is the total evaluation process for this course. Okay, so let me start from the very beginning. So you can see that the title is here. The title for this course is Differential Calculus and Coordinate Geometry. Okay, so we all know that calculus has two parts generally, that is differential calculus, and integral calculus, that is differentiation and integration. Okay, so in this course, we are just here to learn differential calculus. But integral calculus, that is the other part or branch of calculus, integration, will be taught in the next course, which is known as Math 120. Okay, this is 110, and there is another course which is known as Math 120. So here, besides differential calculus, you can see that we have another part that is attached, which is known as coordinate geometry. Okay, so you all have the idea of calculus and geometry from your college level. Okay, and we'll try to understand all the basic things of calculus, that is differential calculus and coordinate geometry in this course. And also we will try to learn some applications of differential calculus and coordinate geometry. So we have a virtual platform which is known as BUX. Okay, so here you will get to know the course content, and also you will find the lecture videos. Okay, so I have already shared the BUX link and also the Discord link. Okay, so this BUX link is for the virtual classroom, okay, for Math 110, and this Discord link is for communication. Okay, so if you have any queries regarding the course, if you have any question, then you can ask the faculties, that means the teachers, in Discord. Okay, so please try to join in Discord and try to join or enroll in BUX, okay, where you will find all the lectures for this course. Okay, here the lectures are designed week-wise. Okay, so we have total 13 weeks or 12 weeks. Okay, so the lectures are designed in a way so that we can complete the whole content within these weeks. Okay, so in week 1 you will get to know the basic concepts of differential calculus. Similarly, week 2 to week 11 you have the course outlines and you will learn the contents. Okay, so in the lecture videos of BUX you will have some multiple choice questions. Under each video, there are some multiple choice questions. So you have to just answer those questions based on the video that you have watched from BUX. So this is the virtual platform for all courses that you have, like Math 110. Let's say you have CSE 110 or Physics 110. So for all this course, you have a separate BUX platform. So try to join all the platforms that you have, okay, for all courses that you have taken in this semester. So these are for the beginners. These rules are for the beginners, but those who are already completed this course, you know all the things, okay? And now the main point is what you will get to know from BUX videos. So in BUX, that is in box, you will have the lecture videos, which are mainly theoretical, okay? So this course has the theoretical part and also the applied part or problem solving part. So in BUX, you will get to know all the theoretical concepts of this course, and whatever classes we have, that means like today, we are having this session. So in these sessions, we will learn about problem solving, okay? So from BUX lectures, you will get to know the theoretical concepts, and the session that I will take in these sessions, you will get to know some parts or review of theoretical concepts, and the main concept that we will share here, that is, we will solve some problems based on the theoretical concepts, okay? Suppose we are going to solve some differentiation problem. We are going to find the maximum or minimum of a function. We are going to find domain and range, okay? So in these sessions, that means the classes that you have to attend, okay? So here you will learn about problem solving. But at first, before coming to every session, please do watch the lecture videos of that week. Otherwise, you will not understand the theoretical concept. So if you have the theoretical concept, then you can understand the problem solving. So let me give you the outline of this course. That means whenever you will enroll in BUX, you will see that week by week, some contents are coming, okay? The contents will be released week-wise. That means in week 1, the basic concepts of differentiation will be released. In week 2, you will get to know some other contents. Similarly, the process will be going on. But here, since this is the introductory session, I will share all the course outlines, okay, so that you can have the idea what contents you have in this course. So at first, let me write this term again, that is differential calculus. You know that the title is differential calculus and coordinate geometry. So differential calculus has been classified into 3 categories here in this course. So at first, you have to know single variable function. So which functions are single variable function? You already know that if we have y equals f of x form, where x is the input and y is the output, then we can say that the number of input is only one, which is x, and the number of output is y. Okay, we don't need to count the number of output. The number of output will be always one, but we have to focus on the number of input. How many inputs we have? We have only one input. The variable or letter that is enclosed in the parenthesis of brackets. So that is known as input variable. So since we have x as the input, let's say we have y equals x squared, or let's say we have f of x equals x plus 1. Suppose we have g of x equals x squared plus 5x plus 6. Suppose we have ace of x equals sine x. So you can understand that suppose we have f2x equals log x plus e power x. So you can see that every time on the right side, we have a single variable, x. You can see log x, e power x. So that means all these functions have the form y equals f of x. So we will learn how to differentiate this type of functions. You already know the idea how to differentiate this type of functions, but we will try to review again these concepts. So our target is to find, let's say, the derivative of this function dy dx or f prime of x. If we have y equals f of x, our target is to find the derivative of that function. So this is the differentiation of single variable function. So in this course, at first, you will learn about how to find the derivatives or differentiation of y equals f of x. Then you have to go through the contents, which is known as multivariable functions. So which functions are multivariable? Let me give you examples. So y equals f of x, you can see the number of input, that is only x. It is just one. So that's why single input variable or single variable. Similarly, if we have more than one variable inside this parenthesis or brackets, let's say we have x, y, z, we have 3 variables inside. That means the variables or letters that we see inside the brackets are the inputs. And we will have, let's say, output z. Here, let's say we have output p. So you can see that the number of inputs is more than 1. Here we have 2 inputs. Here we have 3 inputs, x, y, z. So that means we can say this is function of 2 input variable. This is a function of 3 input variables. So combinedly, if we try to give a general name, then we can say that these functions are known as multivariable functions. So we have to know how to find the derivatives of these functions, just like this one. So for single variable function f of x, we will use this notation d dx. But for multivariable functions, let's say you have a function f of x, y equals x squared plus y squared plus 5. Okay, so you can see that the number of inputs this time is 2, x and y. At first, you have to input some values of x and y, then you can get the functional value. Or let's say this is z. So z will be 1 plus 4 plus 5, that means 10. So at first, we have to input some values of x and y, then only it is possible to find z. So how many inputs we have? We have 2 inputs. So this is a function of 2 variables. Depending on 2 input variables, we can name this function that is multivariable function. Similarly, we may have x squared plus xy negative y plus, let's say, z. So how many variables we have here? We have 3 input variables, x, y, and z. This function is a combination of x, y, and z. So suppose I need to find the value of p when x is 0, y is 1, z is, let's say, 2. So at first, I need to input x, y, and z. Then only it is possible to find the value of p. Okay, so p equals 0 plus 0. If we calculate this one, it is 1. So finally, p equals 1. That means we are plugging 3 inputs, x, y, and z. So we have to know what is the name of these functions. This is function of 3 input variables, or in general, we can say it is multivariable function. So for multivariable function, the derivative or differentiation is not like ddx. Here, since the number of inputs is more than 1, it may be 2, maybe 3, maybe 4. So here we will use a different notation. Instead of ddx, we will use d dx. This is also d, but this is curly d, or which is known as partial d. Okay, so we have to find the partial derivatives, but this simple d is known as ordinary derivative symbol, but this is the symbol for partial derivative, that is curly d, partial d, or we can say this is sometimes also called del. Okay, so ddx, ddy, let's say we are going to find ddz for which function? For, let's say, f, df dx, df dy, df dz. Okay, so how to find the derivatives for multivariable function, that will be discussed here. So after single variable function and multivariable function, there is another part that is attached under differential calculus, which is known as vector calculus. So in vector calculus, you will get to know the vector fields, gradient, divergence, and curl. So all gradient, divergence, and curl, okay, depends on derivatives. That is, instead of d, del, we will use this symbol. This is also known as del, or we can say this is the symbol nabla. Okay, NABLA. Okay, so here, since I have written vector, so you know that a vector can be two-dimensional, that is 2i plus 3j. Let's say a vector. We may have a different vector. Let's say we have 3i plus j plus 4k. So you can understand that we have a vector, let's say 3i plus 1j, no need to write 1, and let's say 4k. So you have already learned about vectors in your college level, but here we will learn that a vector, besides being constant here, we may have also a function. Let's say f of x comma y comma z I, it is f1. Instead of 3, we may have a function, multivariable function. Instead of 1, we may have f2 x comma y comma z. Since there are 3 inputs, x comma y comma z, how we can understand that x comma y comma z are inputs? Because these are enclosed in parentheses. Okay, so f1, f2 plus, instead of 4, we have f3 x comma y comma z k, I cap, j cap, and k cap, or I hat, j hat, and k hat. You know that I, j, and k hats are unit vectors, standard unit vectors. So I am not going to details of this part, but here the main theme is, instead of constants, instead of constant values like 3, 1, and 4, we may have a function. So we have to know how to deal with this type of vectors. So instead of vector, we can name these vectors as vector fields. So let me share one thing here. I'm not sure whether I can continue the session more than 45 minutes or not, because Zoom has restriction, you know. So if the session gets disconnected after 45 minutes, I will request you, please try to join again in this same link. Okay, we will be here up to 7:50 p.m. because our classes duration are 1 hour 20 minutes. So here you can see that instead of constants, we have some vectors where we have functions. So we need to know how we can find the derivatives for these vector fields. So this is a big question. So here, just like d for ordinary derivative, just like del or curly d or partial d, we will also use another symbol that is known as del or nabla. Okay, so our main target for this course is to learn how to find derivatives for all these functions, maybe single valued function or single variable function and multivariable function. Besides this, we will learn about how to find the derivative of vector fields, which is known as vector calculus. So this is the short summary of the contents of differential calculus. Okay, These parts are under differential calculus. So let me write the week by week contents so that you can get the total syllabus for this course at the same time. So in BUX, you know that from BUX, you have to go through the lecture videos, which are theoreticals. So in BUX, all the contents are designed week by week wise. Okay, so in week 1, that means the current week from Saturday to Thursday. So what you will learn here, you will learn about introduction of differential calculus. You will learn about limits. You will learn about continuity. So I have mentioned that there are 3 contents or fields under differential calculus: single variable calculus, multivariable calculus, and vector calculus. So y equals f of x, this is known as single variable function. F of x comma y, that is equal to z, or f of x comma y comma z, that is equal to p. So this is known as multivariable function. So week 1 to week 5, these 5 weeks are for single variable function. That means here you will get to know how to find the derivatives dy dx for function of single variable dy dx. So in week 1, you will learn about the introduction. You will learn about limits of f of x function. You will learn about continuity of single variable function. That means introduction of limits and continuity will be found in week 1. So let's see what we have in week 2. So week 2 and week 3 can be merged because these 2 contents are for differentiation. So here in week 2, you will get to know about differentiation. That means we can say introduction to differentiation. Okay. You will learn about differentiability. Differentiability means whether a function is differentiable or not. Can you differentiate a function? That is known as differentiability. So differentiability. Differentiability of which function? This type of functions. Single variable function. Y equals f of x. Okay. That means week 1 to 5 are designed for finding derivatives of single valued or single variable function. So here, besides introduction to differentiation and differentiability, you will learn about some techniques, how to do differentiation or how to find derivatives for single variable function. So you will learn about techniques of differentiation. So under techniques of differentiation, you will learn about chain rule. You will learn about, let's say, how to find higher derivatives. From your college level, you know that if f of x is a function. Then its first derivative is f prime x. Its second derivative is f double prime x. Third derivative, f triple prime x, and so on. Okay. By this, we can find up to nth derivative. So this is known as higher derivative. So we'll learn about higher derivative here. That is in week 2. We'll also learn about the techniques of differentiation in week 3 again. So here you will learn about parametric differentiation. So this is a new term for you, parametric differentiation. You will learn about logarithmic differentiation. So besides this, you will learn about gradient and tangents. So try to understand that in week 1, we have the introduction to limits and continuity. That is the first content for this course. Then in week 2 and week 3, we will learn about all the rules that we have in differentiation. So let us come to week 4. So in week 4, you will learn about the application of differentiation. So application means the real life problems that you have that can be solved by differentiation. Okay, so first of all, we'll try to understand optimization problem. That means optimization means we'll try to find maximum or minimum for function of single variable f of x. Okay, these are also known as extremum, maximum, minimum, extremum. If we try to find both maxima and minima, then we can say extrema. Okay, so extremum and extrema, singular and plural. So in week 4, you will have the applied version of differential calculus. And then we have 2 important theorems to learn here. The first theorem is Rolle's theorem, and another theorem is mean value theorem. So this is about week 4. Now in week 5, we will learn about another 2 theorems, okay, or series that we know. It is Taylor series or Taylor polynomials and Maclaurin series or polynomials. So Taylor series, Maclaurin series will be discussed in week 5. So week 1 to 5 is about finding derivatives for single variable function f of x. You will see all the way this type of functions f of x. Okay, and now after week 5, we will move to multivariable function. So here, you know that the function will take the look as f of x comma y or f of x comma y comma z. We may have the output as z or p, like that. Okay, so now we have week 6 contents. So first, you will learn about partial derivatives. That means I have already mentioned that partial symbol is this curly d. You will learn about how to find the derivative for this type of functions: df dx, df dy, df dz. Okay, so besides partial derivatives, you will learn about the techniques of partial derivative. Okay, in ordinary derivative, I have mentioned that we have some techniques: chain rule, parametric differentiation, logarithmic differentiation. So besides this one, in week 6, we have to know some techniques of partial derivatives. Here you will also find chain rule for partial derivative. You will also find higher derivatives for multivariable function. Let's say this is the first derivative. Similarly, we have the second derivative of f, second derivative of f in terms of y, third derivative of f, okay, in terms of x, third derivative of f in terms of y. That means this type of contents will be discussed in week 6. And then after week 6, we have again maximum and minimum. So this will be found in week 7. Okay. In week 7, we have again the optimization problem, that is maximum and minimum, but not for f of x. Here we will learn for how to find maximum and minimum for f of x comma y, f of x comma y comma z. Especially we will focus on how to find the maximum and minimum for f of x comma y. Okay, so this is the contents for week 7. And then week 8. In week 8, you will learn about a content that is known as Lagrange multiplier. Okay, actually it will be found in week 9. So I am writing week 9 at first because Lagrange multipliers is a special type of method that can be applied to find maxima or minima for function of multivariable or multivariable functions. So 7 and 9 can be merged, but inside 7 and 9, we have week 8. So in week 8, we will start another part that is under the umbrella of differential calculus, which is known as vector calculus. So in week 8, we will start vector calculus. So in vector calculus, we have to find the maximum, we have to find the derivatives of vector fields. So here you will see vector fields. So I have already mentioned that which one is vector field. If we have, let's say, we have a vector f1 x comma y comma z I cap plus f2 x comma y comma z j cap, f3 x comma y comma z k cap. So this type of vectors has functions involved. So this is known as vector fields. So we'll have a look on vector fields here, and then we'll try to learn the derivatives of vector calculus or of vector fields, that is known as gradient, divergence, and curl. So you are familiar with these terms from your college level. In physics, you have learned, or you have the idea of gradient, divergence, and curl. So we'll try to focus these contents in week 8. So in week 8, you will learn about the derivatives of vector fields. So this concept will be applied in week 9. Lagrange multiplier. In week 5, you will learn about Taylor series and Maclaurin series for function of single variable. But whenever we will start multivariable function, then in week 7, we'll also focus on Taylor series. Okay, but not for f of x. We'll focus on how to find the Taylor series for f of x comma y. Okay, so after week 8 and 9, we can start the last section of this course, that is known as coordinate geometry. Okay, so in coordinate geometry, we have conic sections, parabola, ellipse, hyperbola, circle. We learn about some coordinates. So let's say we are in week 10. So in week 10, we will focus on conic sections. So we may have parabola. We will learn about ellipse. We will learn about hyperbola. We'll also learn about circle. So circle and ellipse can be understood together. So that's why we can also say that circle is one kind of ellipse. Okay, so these things will be discussed in week 10. Then in week 11, we'll try to know some coordinate systems, that is known as polar coordinate. Polar coordinate means we will deal with r and theta. So you know that we have the Cartesian axis, that is x-axis and y-axis. If we think about 3 dimension, then we have x-axis, y-axis, and z-axis. This is 2 dimension. This is 3 dimension. So these are known as rectangular coordinate system or Cartesian coordinate system, where we have a point, let's say x comma y. We have a point in 3 dimension, x comma y comma z. Okay. But besides this Cartesian coordinate system, we have also some other coordinate systems. Okay. That is known as, let's say, polar coordinate, where instead of x comma y, we will convert the coordinate to r and theta. That means this is r and this angle is theta. So by this, x and y will be converted to r and theta. So there is a process how to do that. And then after polar coordinate system, we learn about cylindrical coordinate system. So in cylindrical coordinate system, we have r, theta, and z. So you can understand that r and theta, this is about 2 dimension. But since we have r, theta, and z, so this is obviously 3 dimension. So that means if we have a point x comma y comma z, then we have to know how to convert that 3-dimensional point to r, okay, r, theta, and z. This is how we can understand the position of the point that we have x comma y comma z. So we have theta here. So this is about cylindrical coordinate system. After cylindrical coordinate system, we will focus on spherical coordinate system. So again, a spherical coordinate system is a 3-dimensional system where x, y, and z will be converted to rho, theta, and phi. Okay, so we will discuss about these things later, but the target of this session is to give you the overall summary of the course. Okay, so you can understand that by cylindrical, you can understand we may have a cylinder. By spherical, you can understand that we have a sphere. Okay, so if we want to convert x, y, z to cylindrical point r, theta, and z, then we will consider a cylinder here. If we have to convert a point that is in x axis, y axis, and z axis, so we will apply now, let's say, spherical coordinate system. So instead of x, y, and z axis, we will apply spherical coordinate system. So instead of x, y, z, we are thinking about we have a sphere. So these are advanced rules and methods by which you will learn how to understand the location of any point based on cylindrical or spherical. So this is the contents. This is all about the contents that we have in this course, Math 110 or Math 110. Okay. Now, let me focus on the mark distribution or overall grading system for this course. You have to know what is the evaluation process. Okay. So We have some categories. At first, we have marks on attendance. Okay, that means the live sessions that we are having here. So these sessions are mandatory. So if you join these sessions, you will get marks that is known as participation marks or attendance mark. If you attend more than 90% classes, then you will get 5. So in attendance, we have total 5 marks. Now, let me write another evaluation process. We have quizzes. There will be 3 quizzes. Quiz 1, quiz 2, quiz 3. So for quizzes, we have total 25 marks. Then we have assignments. After 1 or 2 weeks, you will be assigned some problems. Okay. So based on assignments, we will evaluate your script. So there will be 4 assignments: assignment 1, assignment 2, 3, and 4. So this will contain 20 marks. Then we will have a midterm. So in midterm, the mark distribution will be 20. And then we have finally the last evaluation process, which is known as final exam. In final exam, the mark distribution is 20. That is, total mark will be 20. And the last evaluation process of this course is the final viva. Okay, so the viva will be based on the overall course from week 1 to week 11. So viva will contain 10 marks. So you can understand that total 5, 25, 30, 50, and 50, total 100 marks. So this is the mark distribution for this course. Besides BUX lectures, you have to attend these lectures that I will conduct. Okay, in BUX, you will find the lectures which will be mainly on theoretical, but the sessions that I will conduct will be based on problem solving. So the important part of this course is the reference book. So we will mainly follow 2 books for this entire course. So you can either follow Calculus written by Anton. Okay, it may be 9th edition or 10th edition. Another thing, you can also go through Calculus written by Stewart. Let me show which contents we can go through from these books for better understanding of all the contents. So let me open the content part. So our week 1 is based on limits and continuity. So you can see that there is a chapter on limits and continuity. Then we will focus on derivatives, techniques of differentiation. That is, here it is written as topics in differentiation, implicit differentiation, parametric differentiation, logarithmic differentiation. So these things are here. And then you understand that we have some applied part, how to find maxima, minima. So this part can be found here. And then we have two theorems, Rolle's theorem, mean value theorem. So if we follow this book, then the things that we have here, let me mark. Chapter 1, chapter 2, we have chapter 3, chapter 4. Okay. Then we have Taylor series and Maclaurin series. This will be found in chapter 9. So chapter 9, 1, 2, 3, 4, then 9. Okay, this is for function of single variable or single variable function. Then we'll focus on chapter 10 for coordinate geometry. You can see polar coordinate is here. We have cylindrical coordinate. We have a spherical coordinate. So chapter 10 and 11 are in your syllabus. And then you know that we have a part that is known as vector calculus. So vector calculus will be found in chapter 12 and in chapter 15. After chapter 12 and 15, we will focus on also this one, chapter 13, partial derivatives. So these are the things that we can go through from this book. Okay, let me again show the contents. So chapter 1, 2, 3, 4. Then from chapter 9, 9.7, 9.8. In chapter 10, polar coordinate. From chapter 11, cylindrical and spherical coordinate. Chapter 12, chapter 13, and chapter 15. So if we follow this book, then we can go through these contents. If you want to go through this book written by Stewart, so again, the contents will be similar. We can have a look on chapter 2, okay, chapter 3, chapter 4, and then chapter 10, only polar coordinate part. Then Taylor and Maclaurin series from chapter 11. Chapter 12 is obviously vector. So you will get to know the properties of vectors here. Then we have vector valued function, chapter 13. Chapter 14 is partial derivative. That is also included in your syllabus. Okay. And then finally, this one, chapter 16. So I have a playlist that is based on some contents of this course. It is not fulfilled, okay? But you will find most of the contents of this course, which I have taken in previous semesters. Okay, so you can see that you have introduction, limits, continuity. Here you have a derivative lecture. You have a lecture on differentiation. You have a lecture on L'Hopital rule, then lectures on maxima, minima, partial derivatives, vector calculus, and Taylor expansion for function of two variables or multivariables. So you can go through these lectures. I am sharing the playlist here. So this will be your supplementary parts. Okay, you can see the sessions are very long, so you can go through with playback speed. Okay, so you can also go through this one besides your BUX lectures.